Training GPT-3 cost $4.6 million. But what if you could capture 95% of that intelligence? For $10. Every AI breakthrough you've heard of, ChatGPT understanding your questions, Google sorting billions of searches, GitHub Copilot writing your code. They all use one technique. It's not bigger models. It's not more data. It's the ability to take a general-purpose brain and teach it your specific task. This is transfer learning and fine-tuning, the most important idea in modern AI. And after this video, you'll understand exactly how to use it. Let's set the stage. In the last video, we met BERT and GPT, massive models pre-trained on the entire internet. BERT learned to understand language by reading billions of pages bidirectionally. GPT learned to generate language by predicting the next word, trillions of times. But here's the problem. These models know everything about language in general, and nothing about your specific task. BERT can understand sentiment in theory, but it's never seen your product reviews. GPT can write anything, but it doesn't know your company's style guide. The old solution? Train a model from scratch for each task. Cost, millions of dollars. Time, months. Data needed, billions of examples. The new solution? Take an existing genius and give it a quick tutorial. Transfer learning is one of the most elegant ideas in all of AI. Here's the core insight. Knowledge learned for one task can be transferred to another. Think of it like education. You spend years learning to read, write, do math. That's your pre-training. Then when you start medical school, you don't relearn the alphabet. You transfer that foundation and specialize. Neural networks work the same way. The early layers of a pre-trained model learn universal patterns. What edges look like, how sentences flow, what grammar means. The deeper layers learn increasingly specific features. Transfer learning exploits this hierarchy. Take a model pre-trained on massive data. Keep its universal knowledge. Adapt only what's needed for your task. The simplest approach is called feature extraction. You freeze all the pre-trained layers. Lock them in place. Then you add a small new layer on top, specific to your task. Only this tiny new layer learns. It's like hiring an expert translator and just teaching them your company's jargon. You don't reteach them the language. You leverage their existing knowledge. The result? With just 100 labeled examples, you can build a model that rivals systems trained on millions. But feature extraction has limits. What if your task is very different from what the model originally learned? That's where fine-tuning goes deeper. Strategy 1. Full fine-tuning. You unfreeze all layers and train the entire model on your data. Maximum adaptability, but risky. You need enough data, or the model forgets what it knew. Strategy 2. Gradual unfreezing. You start by training only the top layer. Then you unfreeze the next layer down. Then the next. Layer by layer, you gently wake the model up. This technique, from ULMFIT in 2018, was revolutionary. Strategy 3. LoRA, low-rank adaptation. The cutting-edge approach from 2021. Instead of changing the original weights, you add tiny trainable matrices alongside them. The original model stays frozen. The adapters learn the difference. LoRA is stunning because the adapters are often less than 1% of the original model's size. You can fine-tune a 175 billion parameter model by training just 2 million parameters. So how does this actually work in practice? Here's the 5-step workflow. Step 1. Choose your pre-trained model. BERT for understanding tasks. GPT for generation. T5 for both. Step 2. Prepare your data. The magic of fine-tuning? You might need as few as 100 examples. For most tasks, 1,000 is plenty. Step 3. Set your learning rate. This is critical. Too high, and you destroy the pre-trained knowledge, a phenomenon called catastrophic forgetting. Too low, and the model barely adapts. The sweet spot? Usually 10 to 100 times smaller than training from scratch. Step 4. Train for just a few epochs. Often 2 to 5 is enough. Step 5. Evaluate. If it works, deploy. If not, adjust strategy. The entire process takes minutes to hours, not months. Now here's where everything gets flipped on its head. Fine-tuning changed the game. But in 2020, GPT-3 revealed something nobody expected. You didn't need to fine-tune at all. Zero-shot learning. You just describe the task. Classify this review as positive or negative. And GPT-3 does it. No training data. No gradient updates. No fine-tuning. Few-shot learning takes it further. Show the model 3 examples in the prompt itself. Review, great product. Positive. Review, terrible quality. Negative. Review, best purchase ever. And the model completes it correctly. Then came instruction tuning, the technique behind ChatGPT. Instead of training on predict the next word, you train on follow the instruction. Instruct GPT, Flan, and their descendants learn to do what you ask, not just what comes next. Think about what just happened. We went from training models from scratch, costing millions, to fine-tuning pre-trained models, costing dollars, to prompting models, costing pennies. 3 paradigm shifts in 5 years. This changes everything, and I mean everything. In 2018, using state-of-the-art NLP required a PhD and a supercomputer. Today, a student with a laptop can fine-tune BERT in Google Colab for free. A developer can build a custom chatbot by writing a prompt. Here's how to choose your approach. Lots of labeled data and a specific task? Fine-tune. Limited data but a clear format? Few-shot prompt. Need maximum control? LoRA adapters. Quick prototype? 0 shot. The cost of AI capability has collapsed by a factor of 1 million in just 5 years. And it's still falling. In the next video, we'll explore how to measure whether your model actually works. Evaluation metrics like BLEU, Rouge, and Perplexity. Plus the emerging art of prompt engineering. If this breakdown helped you understand the most important technique in modern AI, hit subscribe. Every video in this series builds on the last. And trust me, the next one reveals why most people evaluate their AI models completely wrong.